Okay, so let me begin by talking about the STEM and Millennium math problems. Pretty sure I don't have them in order here, but I do have my book handy. And if I may, get it fired up here. So we'll try to keep on 15 minutes, but there's certain notes I want to get to about our early index brick and dryer conversation. See, I'm immediately starting into it. And the order in which we do this is it could be the militia relativity. We could be talking about the key prefix. Again, leadership conversation in Tread Docs is both fundamental, like reading the book analytically, but because analytics and something like Sun Tzu work very differently. I need to know the subject matter of the section I'm in because superposition in this type of universe to the concept of the unitasker or voltage because of lengths of wire, composition, amps, and other things might be at a physical analytical form to the housing in which the finished form, globular, smooth, may be represented to the topology or the button, the ball, whatever your first subject is. That way, everybody has the same way of thinking about what is always the first thing with Python learning that you do. Always, fundamentally. Brick and dryer conjecture, Bell's equality, field theory in special form first to learn Python. And then we'll break it down to its subparts. Because those general parts may say from there, but there are very specific limits about it. Or from here, the timeline of the evolution, if we put the computer chips together, NP problem, and the dope in chips, or how organizations of field theories and concepts also house a geometry in such a way that it makes the energy much more conductive or associated distributive in a proper form. Yeah, the passing through plates like the MOS chip is going to change its field, how that angry pixie is duality, polarization, charm to the next set of what it's supposed to do is an internal house lattice structure confined code which behaves all like zeros and ones, could be grid positions, could be regular sets. See if I can get to it here. But basically, that's x, y, and z, y, f over x stuff. We're going to get into. Let me get back here. What am I looking for? Yeah, here we go. Get a better cleaner of that being Fermat's theorem. And generally I start with erodes. Here, which is erodes conjecture, Google search, eScholarship, PDF. And I think this was around 18, 19, something like that. It's in the same time frame, but I've been on this for a really long time. The chaos conjecture states that as a period over which a durable good monopolist is able to make binding commitments diminishes, the monopolist's ability to exert market power diminishes more so over in the limit. As the period of commitment becomes infinitesimal, market power vanishes and the monopolist's reproducibility to competitive outcomes. There are two states in which this conjecture may be incorrect. Now, at that point, let's begin the conversation because I'll like you to hear what the intro of this is comparison to some of these concepts.
Hello, everybody, and welcome to Chapter 1 of Python for Everybody. I'm Charles Severance. I'm your instructor, and I welcome you to this class. The basic goal of this class is to teach everybody how to program, regardless of your background. You don't have to be a math whiz. You don't have to be a computer expert. No matter how old you are or what your background is, we want to teach you how to program. So welcome to the course. Welcome to Chapter 1.
Or how to talk about it by not knowing the object shape,
the first
or how
thing
it
to
will
understand
affect
is
the environment that you don't know
the purpose
completely.
to learn to program is because computers want to do things for us. They are built and created and designed, and their hardware is set up so that they basically ask us, what do you want to do next? If you grab your phone...
Well, that would give you that kind of...
Your phone sort of does nothing until you tell it what to do.
It's not exactly
waits
right.
For you.
Well, this
and it's just waiting for you, and all the hardware, computer technology around you is generally waiting for you. And we can use this for useful things.
Plus
we
electricity.
Could play video games. We could.
But is it AC, DC? How does it change the watts?
Someday we might even have self-driving cars.
See, those are the limits he's talking about. And we could hack that thing apart, change out some parts, and do a lot of things with it. But they're still at a set of purpose.
Not really understanding this technology, and I think it's important that we learn to tell these computers
Again,
what to
not
do,
very good programmer, trying to learn.
Increasingly
it's hard to get past that when
so,
the diagram axis usually always beta U, beta V, but there's still like a quadrant, like a very simple mechanics to app layout canvas, but from a canvas in a form, it is a button, it is an app, and so they're kind of always the same thing, but they might be in different flavors, charms, or watts or voltage. Obviously, but at that part there are jumps. They'll jump, and the program doesn't work so good. So all that gets done. So you can get the AO parts or whatever logic of this code actually jumps that thing for you over that forbidden S order, forbidden P order, get you past hydrogen and into a state of where AO behaves the mechanics much more functionably so it can properly function in these fundamental analyses of things that we really understand. See, again, these are very terrifying things to people, but I've seen everybody do it, and 100% anybody can do this. 100% the limit will certainly be based off of your averages, tries and throws. We have to first learn how one of those things now, like the first programmer, is still going to be in effect to you. And you'll get comfortable with things. You'll get areas around town running a circuit, doing things, passing through the grocery store, fixing your attitude.
I've been a paid programmer most of my life, and
some of these are things about organization of students and other things.
You have to use your brain. I'll just say that it has been nice for my career to not be exposed to the elements, but to be able to work often wherever I want.
But again, having a safety officer, having ROTCs and stuff, they're special programs running the loops.
Maybe you have a job as an accountant, or a lawyer, or something else, and maybe you run across some data. Maybe there's
sometimes there's sensors. Sometimes it's inverted square. Like I see the fuzz, the voltage on the multimeter.
Write a program to do some analysis,
or the Arduino, some jumps and ones and zeros to the reset 888 clock.
Right?
There are some heavy duty stuff before you get to Python. Heavy stuff. But then that computer's made. And all this was made.
A million users using your software. If it works for you, then we're happy.
And that's a program that slides in there just like those packs do. Just like how some of those shadow problems work in the mill. Programmers. Like you're going to follow my actions, you're going to do a lot of timeline, frame rates,
you look
training.
At this from the outside, and you see it from the outside, and you click on things. I want to turn this around, and I want you to be the person inside this looking out at the world. And as a programmer, we are making things inside these computers for the world. And so we want to pull you into being part of this. We want you inside this, or thinking.
We want you to want this corner. Go to your corner. Okay.
What you learn is that if you're inside this computer and you are taking your instructions to build programs to be used by the human, the human outside the computer, you have things that you need to take advantage of. There's things like the central processing unit, the memory of this system, the network connection of this system, the disk drive or permanent storage on this system. And as a programmer, you are kind of mediating between all those internal resources that this has that are not very smart but highly powerful, and mediating with what that user wants, right? And so we take the end user, and we programmers, we serve the end user, but the computer serves us. So together, between us and all the computer's resources, we can serve the needs of the end user. And we do this by writing code or programming, okay? And what is that? Well, programming is a sequence of instructions where we are giving instructions to the resources inside the computer in a way to accomplish the goals of the end user. And remember, sometimes we are our own end user. It's not just it's not just, you know,
it's
you're
not
always doing a startup. You're not always writing a mobile gaming system. Sometimes you're writing something for yourself, but that's okay.
That's very true. That is very true.
So sometimes you're writing something to solve a problem.
Might be equity.
You're like crafting. You're doing something that you could do by hand or manually. And you're making,
like I said, there comes times where if you do not know the ones and zeros, the proper organization,
like
you can't weld anything to it. You can't. You are.
It is my creativity. I've got an idea, and I want to share it with a million users.
The mechanics for it, operating position, the office board position, or the Sawyer's hard case, and some of that stuff that might be necessary.
Doesn't know how to hand a roster out, but I can write code that will hand a roster out by looking.
But that would be a very simple limit for me.
This computer
I would need that because something's messing up my jump.
About programs, we have programs for computers and programs for humans. And a number of years ago, now sooner or later this will be me showing my age. This is an example of the Macarena. And the Macarena is a song that effectively is a sequence of instructions. You put your left hand out, you put your right hand out, you put it on the shoulder, you wiggle, 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 and you spin around and you do things. And this is a program for people. And so I want you to take a quick look at this and see if you can find anything wrong with this particular program. So look really closely. So I'll show you. It's got some typographical errors in it, and we as humans are really good at
building a hard counter, moving stuff around, landscaping, weed eating, maps, and a hardscaping quote.
Computers are extremely literal. If
you're doing that in the home gambit,
it would think, what's a ham? And why am I going to hit someone in the back of the head with a ham? And why would I take my left hand and hit somebody? That's, these are all bad things. But the computer is going to take us very literally. And so we have to
weird like
be
that.
Really precise. And the computer just doesn't know the difference between what we mean and what we say.
Once we run that, I can
be very precise. And this is one of
I can walk you through some things
that people have when they first start using computers.
Okay.
And so we have
one of the first things I did is I handed this Mexican guy, didn't speak a word of English. First we do the dance. And the game is to do it a quick handoff because in the training game of tracking them or like NP doping, in training the AO debugging stuff and actions of spooky distances are tough like that to fully quantify. Because again, I mean this all due respect because I'm sure he gets kids on the C++, right?
So the first thing I want to do is I want to throw up some text, and I want you to, while this text is up, I want you to count the number of each word in this text and tell me
that's
what
a limit,
the most
and it works like
common
any.
word is in this text.
Well,
okay?
they're on contract with their kids in college, but you got your 6.7, and you got your boot, right? And 150-1, and that's going to be any site where you're kind of doing some functionable manner of what that is. Make sure we're not running out of time here. Okay, and those would be the cycles. Those would be the loops or the ROM and the corruption and the ROM disk, A money ROM. Yeah, some brother out here with a Quran. Salty Island. You don't do the Marines eating crayon jokes over there? Colored in. Okay, well, anyways, I think that's a good place to talk about why, again, hitting this. Now I just missed another one where I just needed to know how to start pushing buttons.